and hit record. So what's going to cause us to release that aldosterone is because we've got lower amounts of plasma, sodium, higher amounts of potassium. Now, this will also go with lower blood volume and blood pressure. Now, when we are going to be sweating, it turns out we're losing blood volume, and we're also going to go ahead and be losing some of that wonderful sodium. So that's what's going to cause us to release aldosterone. Now, that in turn is going to cause us to go ahead and try to retain more sodium and retain more fluid. And like anything else, it's also going to be indirectly by the pressure that's going through our kidneys. So what we're going to find is our kidneys are going to be directly influenced by antidiuretic hormone and aldosterone. We're going to secrete erythropoietin, and that's going to be the major hormone that's important for increasing red blood cell production from our bone marrow. And this is going to naturally be released in higher amounts when your body is having to go through phases of hypoxia, so lower amounts of oxygen availability. Now, it's going to happen for a myriad of reasons, one of which being obviously that you're exercising at something like, or you're just living at altitude. So you've got a lower partial pressure of oxygen, which we'll get into more in later points of the class, along with you're doing a lot of aerobic style exercise. So you're not able to saturate out as much. And because of this, in turn, we're going to go ahead and build more red blood cells, which obviously has some positive effects. Now, I know it's obviously small on your screen, folks, but make sure that you can go ahead and read through and understand the wonderful flow chart of what's going to happen, of where we're going to start off with sweating. This in turn is going to cause that lower blood pressure, which is going to be affecting our kidneys, which is then going to give us that wonderful effects of now releasing renin, which in turn is going to be converted. It's going to convert angiotensinogen, which is the precursor for angiotensin 1, which is going to occur effectively by the liver. That in turn is going to be affected now by our lungs. And the ACE, angiotensin converting enzyme, ACE enzyme, has actually been an important little thing that came up with COVID, of all things. So keep that in mind. And that's going to convert angiotensin 1 into 2. And then once we get to angiotensin 2, this is where we're going to go ahead and now have our adrenals releasing aldosterone, which is going to give us that vasoconstriction, along with it's going to be limiting the filtering effect that's going to be going from the kidney. And because of this, we are going to obviously be having to effectively urinate less. And this is a good system to have as a means to go ahead and be able to optimize as best we can for our fluid levels when we happen to be exercising. Now, the stimulus for that renin release is going to effectively be lower blood volumes, lower blood pressures. Now, this is also going to come from sympathetic nervous system functioning, where we're going to also cause this. So renin is going to, in turn, activate angiotensinogen into angiotensin. And that's where our ACE enzyme, which is in our lungs, is in turn going to convert us from 1 to 2, and then 2 is in turn going to affect our adrenal cortex. So just keep in mind, it's a flow chart. A is going to affect B, which is going to affect C, which is going to affect D. And this is a good thing, because as we increase our aldosterone, we're going to do a better job of, notice the rapid initial loss of plasma volume, and then how it tapers and tends to hold steadier as our aldosterone level is going to increase, to go ahead and try to manage that. Now, the osmolarity, so this is going to be effectively the amount of protein, ions, cholesterol, all the other different things that are floating in our bloodstream, is going to be around 300 milliosmoles per kilogram of mass. Now, when we happen to have a greater amount of water in our body, or so shall we say a lower osmolarity, we're going to be avoiding pulling water into the bloodstream. And then the antithesis is true. When we have a greater amount of osmolarity, we're going to draw more water into the bloodstream. And this is a normal effect, but we can utilize this actually to try to look a little bit better if we're doing things like bodybuilding, but we can also utilize this as a means to try to make sure we're topping off our water levels as high as we can by taking in electrolytes with it, so we're able to keep our osmolarity up and we're not diluting ourselves. Now, what we're going to find is the greater amount of aldosterone, the more sodium we're going to retain, the higher that osmolarity. The higher the osmolarity, the more we're going to hold on to the water with it. And just think of it along the lines of where the sodium moves, that's where the water is going to follow. And this in turn is going to, once again, decrease our urine output, but it's going to help us maintain our fluid levels much better than we would have otherwise. Now, the effects of aldosterone are going to persist for a while after exercise. This is where you're going to see difference in fluid levels, perhaps days. And in fact, we're going to find that training, especially when you happen to be in the heat and having to sweat a lot, what we're going to actually find is individuals are going to really increase that fluid level when they happen to be in situations where they're sweating for excessively large amounts. Now, the last big component when we're talking about hormones to really understand, which is there's a difference between the total amount of a hormone and the free amount of the hormone. The free amount of the hormone is the hormone that's actually giving us a physiological effect. It's doing the work that we're looking for inside of our body. The total is just how much you have. So you could have a high total, but a low free because the amount that you're essentially bioavailable is pretty low. And on top of that, remember, we need to always keep in mind the numbers of receptors we have available. So if you don't have that many receptors available, your sensitivity for a given hormone is going to be low. And because of that, you are not going to be able to have as great of a physiological effect on the body, given whatever hormone we're talking about. So when we're looking at someone's hormone levels, it's really important to keep in mind that yes, there's reference ranges, but you should still have a good working idea of what is going to be effectively a normal level for someone in your age group, in your health group, and otherwise. And I would really thoroughly suggest all of you guys going to a doc and literally getting every single one of your hormones ran right now, because your levels are going to be probably the healthiest they're going to be for the entirety of your life. So if you have this information now that you can work on, you've got that. So in your 30s, 40s, 50s, 60s, you can compare and perhaps look into doing some type of hormonal intervention to go ahead and get yourself back to those previous levels. So you're going to go back to the levels of performance that you happen to be at beforehand. So who's got questions about endocrinology as we've covered it so far before we're going to get you guys to go ahead and work in groups? Do we have any questions, comments, concerns? All right, guys, so we're going to have you guys divide into groups. It's about 1:34 right now. I'm going to give you guys until, let's say, about 1:44, where you guys are going to go ahead and come back and then talk us through the tissues. So what tissues are going to have the receptors for the hormone that we're talking about, and in what way they're going to affect those tissues. So we're not going to talk about where it comes from, because that's something we've already covered, but I want to talk about the effects that those have physiologically. So if there's no questions, go ahead, make sure you guys are writing all this out. And then whenever we come back at, we'll say 1:45 now, since it's 1:35, that you guys are going to go ahead and one person in the group is going to go ahead and put that in the chat for everybody so we can all read through it and talk our way through it. So have fun, guys, work together and get your learn on. If you don't join the group that you're in within essentially 2 minutes, I'm going to go ahead and put you back in the waiting room, and you will have to message me if you want to come back into the lecture. All right, guys. So Courtney's group, good work, and also is going to have potential positive effects on insulin sensitivity in peripheral tissues, specifically in fat tissues, and potentially a little bit in muscle tissues. Awesome job, Evan's group, with T3. Lexi, insulin doesn't necessarily help your body use glucose as energy. It helps you get it into your muscle cells and your fat cells, not really so much your liver. Okay, so Haley, for testosterone, it does far more than affecting bone and skeletal muscle. It even affects the nervous system to a certain extent, but it definitely affects the hair on your body. So that would be the secondary sex characteristics. And we're still waiting on group 4.
Yeah, I'm in group 4. I was just finishing typing it up really
Okay,
quick.
they're all good. Good, Jessica. A little bit of your fat cells as well, but absolutely. All right, folks. So the next challenge I'm gonna have you guys work on, and it's gonna be in the same groups, which is you can only pick one energy system to maximize in your athlete. So which one would you pick and why? Then we're gonna have you parse between the upper body and the lower body. And if you would then make a different choice for each of them. So you just aim for one for the lower body and one for the upper body. Okay, so remember, we've got ATP PCR, anaerobic glycolysis, aerobic glycolysis, and beta oxidation. So which of those 4 would you want to optimize for your athlete? It's 1:51. We're going to plan on you guys talking together until, say, just plan on being ready to post what you guys came up with at 2 o'clock. So whenever you guys are ready, we're going to go ahead and put you guys back into those rooms. Have fun, discuss it with one another. There's no wrong answer. The key is you guys need to have a rationale as to why you think it would be this, that, or the other. Okay? Get after it. All right, folks. So Nice. And think about it also, you might want to say ATP PCR because if they could smash the crap out of the ball, the other person might not be able to return it because it literally went by them too quickly. But good job, Courtney's group. Evan. Not bad there as well. I can definitely see the logic. I also see the logic for aerobic glycolysis because those rounds are, remember, 3 to 5 minutes, and anaerobic's only going to last us for 2. So you're going to have to need a better energy system. If anything, you probably want the lower body to be more aerobic, just so you can kind of run around and move, but the upper body being more anaerobic. Lexi, interesting. You would actually probably want the lower body to be more of that anaerobic glycolysis because they do it in shifts, but upper body more ATP PCR because they need to hit things hard and fast. Because hockey, they're out there for longer than that. Group 2, Haley's group. Yeah, potentially it probably would just be that ATP PCR. Just go out there and just dominate for a couple seconds and take a break. That's okay. That's why we think through these things. It's not a simple and easy thing. There's always some give and take. Awesome. I agree with you guys with the aerobic for the lower body. Now the key is for a defensive player in soccer, the only thing they're using the upper body for is a throw-in. So that could just be ATP PCR because the rest of the time, yeah, you do use your upper body to counterbalance you and help a little bit with performance in sprinting and running, as you guys all well know. But it's, yeah, I think that's a pretty good setup that you guys got there. Awesome. So the last thing we're going to have you guys work together in groups is you guys are going to be given just a normal person. So they've got their 50% fast twitch, 50% slow twitch with a decent amount of hybrid fibers in there. Now you're going to train them for a number of months, if not years. How are we going to see the muscle fiber type expression change in the muscles they're using for their sport? How are we going to see the energy systems change? So we're going to see more mitochondria, or we're going to see more enzymes related to ATP PCR, to anaerobic glycolysis, etc. So think through it with your group. It's 2:04. We'll make this one obviously a little bit quicker since we're obviously getting a little bit shorter on time, but we're going to meet back at about, say, let's give you guys like 2:12, 2:13. So you guys can go ahead and talk again with your group, come up with your best essentially idea what's going on, and then we can, well, I'll go ahead and kind of give my 2 cents on what you guys came up with. So keep up the good work, guys. Have fun. The rooms are open again. Really think through how those fiber types are going to change. Remember, everybody's pretty much losing the type 2X. Everybody. Now it's going to be the type 2A and the type 1 that's changing. So really think that one through. Have fun. All right, Courtney's group. Good job, guys. You'd see an increased number of mitochondria. You'd see an increased amount of enzymes related to the citric acid cycle, and potentially some for glycolysis, but I do agree with you. Do keep in mind your type 2 fibers are also going to gain a greater amount of mitochondria themselves. So all of your hybrid fibers are going to convert more into the aerobic ones. Good. Okay, now potentially, because remember, there's also the aerobic component for Haley's group when it comes to CrossFit. So you could see actually nearly this, just a loss of your type 2X fibers, but bigger type 1 and type 2A. And then you would actually have to see probably an increase in mitochondria in all the different fiber types, along with the enzymes that are related to those energy systems. Remember, the enzymes are what allow them to run. Yes, yeah, with rock climbing, it's really a lot of type 1. It's just being able to hold those positions. So we're talking about a lot of aerobic and beta oxidation, or aerobic glycolysis and beta oxidation to hold those positions. And, you'll see a hypertrophying of fibers, but definitely a lot more of the type 1s. So good. Now remember, guys, enzymes are how those energy systems work. Remember, there's all those enzymatic steps. So if we go from having one enzyme at each of those steps, well, we can only go a certain speed. But if we have 2 enzymes for each of those steps, we can go at twice the speed. 3 compared to the 1, 3 times the speed. So that's why we want to increase the amount of enzymes, because you've got more than one of every single enzyme inside of your cells. And obviously, the more you have of them, the faster it can run, because every enzyme always runs as fast as it can. The Olympic lifter, you're going to see an increase in type 2A. So all of the hybrid fibers are going to convert more there. They're going to lose the 2X because we're going to lose the couch potato fibers. You're going to see, now remember the enzyme for the ATP PCR system is creatine kinase, CK. So that would definitely increase in level and maybe some anaerobic glycolysis, but you wouldn't see the changes in mitochondria, excuse me, or otherwise. And so we're just waiting on the last group. No, you still need those enzymes related to aerobic glycolysis and beta oxidation. So it's not just increasing the amount of mitochondria, which is like increasing the number of buildings. So, or increasing the number of factories. Now, you still need machines inside of the factories that build what you need. So you can have a relatively big factory that doesn't have many machines in it, or a factory that's smaller, but it is crammed to the gills with all of those enzymes. So all of those machines that are going to build what you want. Yeah. No, yeah, it depends. Jessica, good point. You'd see conversion from the type 2X. You would see that regardless. But then as far as would you see a greater essential change more to the 2A or to the type 1, depends on how much volume of work they're doing. So that is a hard question to answer. And so if they're playing on a team that the defense pretty much can never get them the ball, and they're really powerful and just, they score the ball or score the goal every time they have it, then yes. But if they're a team that they get the ball a lot, but they have a hard time scoring, then arguably you'd see more type 1, but you would definitely see some conversion. So good job, guys. And obviously we've gone over a little bit, but we've been covering information really quickly, obviously in the class, which I'm glad, but at the same time, we don't have those interactions. So we're going to keep doing these small group little exercises and then talking through what those results are for the rest of the term. So stay safe out there, guys. Take care of yourselves. And I will see you guys obviously back here online on Wednesday. So have a great day and see you guys then. Bye-bye.